Hello everybody, welcome to another video on SolidWorks. So in this video what we're going to do is actually talk quickly about how to create assemblies in SolidWorks. So assemblies are fairly important in any engineering context. So I have a couple of objects here, so any object you kind of look around is actually not like a solid object, so you'd be able to move things around, put it together. So this is my kind of like the USB hub, so you notice that there is one piece over here and then there's another piece over here. This is basically plastic, so this, if you are really adventurous, you can pull this apart. This in turn has multiple pieces, so you have this USB interface, and then if you were to pull it apart, you would have the electronic circuit over here. This is another interface over here, so this would be a different piece. This would be metal and so on. Another example, this is actually fairly interesting. So if you have a pen like this, you can actually notice that there is one kind of the refill on the inside, which is one material. There is the plunger over here, and then you have a spring on the inside over here, and then you also have a way, kind of like a groove that's designed over here, and then things move. So to do all of this, you can't actually, or if you were actually designing this in SolidWorks, you don't want to actually make this as a single part. So we are no experts in making single parts, right? So what we need to do is basically move to something known as assemblies. So that's what we're going to be doing today. We'll talk really quickly about what assemblies are, which is what we did already. Talk about assembly constraints. Talk about briefly number of constraints that you would need to fully constrain an assembly. Talk about toolboxes, which are inbuilt components that you can drag into your assembly, and kind of just do like a quick exercise in there. So this is basically what an assembly does, is it logically links different parts together. So you can think of assembly as a collection of parts. So it's not like your trash bag where you just throw stuff in. You actually have a relation between the different objects in your assembly. So that's where you would place the objects in some logical order. Any examples? So if you are watching this on a computer, your monitor is actually kind of an assembly itself. You can look around, so you might have a door, a window, so all of it would have a wooden frame, hinges, so the hinges needs to connect properly. So you can't arbitrarily create assemblies, so you want to have a relation between the different components, and that's where the assembly constraint comes in. When you have two particular objects, the easiest place to start is to have two parallel planes. So if you have two planes, what you can do is make them either parallel to each other, perpendicular to each other, and then you can also make them at a particular angle. So once you have them to be parallel, you can either have them point in the same direction or an opposite direction. So this kind of gives a quick overview of what assembly is. So now what we're going to do is kind of create two square blocks like this, and then see how they are assembled together. So to create an assembly, we would first need to create the individual parts. So I'm going to create a part here. So on the top plane, I'm going to create my sketch. So if I actually do this add dimension over here, it'll automatically add my dimension, so which I can modify later. So I can basically make 50, 50, and then exit. And then I'm going to extrude this and then make it about 100. And then say okay, and then we're going to save this. So what I'm going to do is select this face and then just change the color. So I'm going to make this one say red, and then I'm going to save this, save as, and then we'll call this A2. And then what I'm going to do is select this face and then change the appearance and then maybe we'll make this one to be green. So this is basically, you don't really need to do this. This basically would allow you to distinguish the two objects that we have. So now what I do is I do Control N, and then I'm going to do assembly. I have two options here. So I can either open the existing document, which kind of shows up over here, and then I'm going to, since my A2 is already open, I'm going to drag and put it here. And then what I need is I need an insert component, and then click browse, and then I'm going to select A1. So this is my other object. So just to distinguish, they actually have different colors. So I'm showing kind of like a really simple example, and you can basically do the same thing with more complicated objects. So we try to save this. Notice that the extension is a little bit different. So we'll call this video 4a again. And then this is saved as an assembly. So now you can, if I grab hold of this, I can actually move the component. If I wanted to rotate it, I can also select and rotate the component any which way I want. So I've just made it to be an arbitrary location. If I try to drag on the first object, it's kind of locked in place. It's kind of locked in place. So what I would do, so I just put it at a weird angle to see what happens. So if I wanted to move the first object, what I first need to do is right click on it, and then say float object, and then I would be able to move the object. So once I've done that, I'm going to lock this in place. So it's always good to fix the first object that you have in your assembly so that things don't move all over the place. So now we are in isometric view, right? So what I'm going to do is I can do one of two things. So if I select these two faces, SolidWorks will automatically give me the assembly constraint options. Here we have the option of making them coincidental, parallel, perpendicular, at a distance, or at an angle. So these are the only few things you can do with two planes. I can also lock them relative to each other. So what I'm going to do is make them coincidental. So when I make them coincidental, I can have them face in the same direction or have them face in the opposite direction. So if I wanted to have them face in the opposite direction, so I'm going to edit the feature, and then I'm going to flip the direction. So if I did this, now they're facing each other, right? So you can do this the other way, and then they are now at a different way. I can also make them parallel. So the difference is they could potentially be at a distance separating them. I can make the two faces perpendicular, or I can make them at a particular distance. So this basically, if I increase the distance, the object basically moves. I can also flip the direction in which I put the distance over here. So this object is kind of fixed in place. This object is still able to move in this particular plane. Since I have actually locked the two faces, so if I try to rotate this object, I can only rotate it in this plane. If I try to grab hold of the other edge, it doesn't actually rotate. It's actually fixed in place. What I can actually do is if I select these two planes and then make them parallel, now the only thing the object can do is kind of like move around. So this kind of does the constraint for the two planes together. So this, if you had a circle, you would do slightly different constraints. The constraint you can do is, if you think of the example of a table, you can think how things will be done. So you'd have the tabletop, it will be aligned here, this face would be perpendicular to this face, and so on and so forth. So we'll try to do this table example really quickly. So in order to do that, I'm going to create the top of the table and then the two legs. So we're going to create a part again. So top plane, and then I'm going to create my sketch. And then I'm going to extrude it, and then 10 millimeters is okay for now. So this is going to be my video B. And then I'm going to save this as my leg and then just change the dimensions. So my leg is going to be 10 by 10. So it automatically put this equality constraint for me. And then I'm going to make the leg a little bit longer. So make it 100 millimeters long. And then we'll save it. We go Control N. This is going to be my assembly. So now I have A2. I don't actually want this. So if I hit escape, so what I can actually do is I'm going to save this first. For B. And then what I'm going to do is insert component, and then I want B1, video B1 is, which is going to be, saved it as B1 over here, which is my tabletop. And then I'm going to insert just one leg, which I called it B2. And then I'm going to basically select this face, and then make them coincidental. I'm going to select this face, make it coincidental as well. So now what I can actually do is see how I can still move the object. So I'm going to grab hold of this and then I can move it here. Notice that if I move my mouse this way or that way, it's not moving the object in that particular plane. What I need to do is select this face and then select the bottom face. Oh, I'm pressing bin. So select these two faces, and then if I didn't have the prompt, I can actually click on the mate here, and then it's basically made them coincidental as well, and then say OK. Right. So now my table has one leg and it's fully constrained. I can actually do the same thing again and again. So what I'm going to do now is, since I'm lazy, I'm going to basically copy this particular leg with all of its mates. So I'm going to right click on this object and then select copy with mate. And then it says, okay, do you want to keep trying to mate the new object with the same face? I'm going to say okay. And then this one, it says, okay, I'm going to put the leg on this side. So I'm going to say, okay, keep this mate. The next mate is this one. I'm going to say, you know what, I don't want that mate. So let's do this one first. So I'm going to say repeat. And then what I'm going to do is try to say, okay, I'm going to mate instead of this face. I'm going to say, okay, I'm going to mate it with this face. It says I can't do that. So I'm going to select this one and then try to do this. Now my leg is kind of flipped over. So let's see if I flip it. If it does it okay, notice that my legs aren't quite aligned. So I'm going to say okay for now, and then try to fix it. So you could try to kind of work around, and then so the easiest way to do it is click the object, figure out which one this is, and then go to the mates here, and then say, okay, this mate I need, this mate is what I need, this mate is kind of messed out. I can try editing this mate, but in my experience I found it actually causes more problems. So what I'm actually going to do is delete this mate. And then I'm going to create a new one, select this face, and then make them coincident. So I can repeat the same thing for the other faces, and then I'll be done with my leg. So I'll leave that as your exercise. So the next thing we're going to do is think about concentric mates. So this is mainly useful when you have cylindrical objects and you want to make the two circles concentric. So this is mainly applied for cylindrical objects. So to do that, again, go back to my SolidWorks. So I'm going to create a new part, save. This is going to be week 04 C, oops, video 04 1. So I'm going to create my shape on the front view. I'm going to make a rotated symmetric, so let's make it say 80 millimeters high, 80 millimeters wide. I'm going to create, I'm going to create another like so, which I'm going to create say 45. This maybe make it 20. Actually, I don't care about that. I'm going to basically dimension this, and this will make this 20, and then we'll make this height to be 30. Now I'm actually going to use my power trim and then delete things I don't need. So I'm going to go foo. So I'm ended up with this particular shape. I can basically edit the sketch again. So what I'm going to do is select this point, merge them. Actually, I'm going to go power trim and then get rid of this guy. So now I've actually deleted this dimension, so we need to add that here. And then I deleted this dimension, so we would add that here as well. Now I'm going to go revolve. So it's easier if you select the sketch first, and then I'm going to select this is going to be my axis, and then this gives me this particular cylindrical shape. So we'll save, create a new one, and then I'm just going to select top plane, create my circle, and extrude it out. So we'll create this as 15 and then extrude it out, and then say OK and save this. So here is my new part, new assembly. So now I should probably close all of the other things. So I'm going to basically select my C is basically this, and then create insert part, and then we'll click C2 as well, which is a little peg, and then say OK. So now if I wanted to select this cylindrical part, there are a few things I can do. So the easiest thing to do is to make concentric, which is basically the center of the two circles are basically aligned. So the cylinder can still move up or down, and then technically it can actually rotate, but then you don't really see that because it's a cylindrical object. Let's see if we can do this. I don't know if you can see it rotate on the video, but it's useful if you wanted to fully constrain the cylindrical objects. You're not really concerned about it rotating about its axis. So the really cool thing about the assembly is I can edit the shape, so which is this guy. I can either edit the sketch from here. So if I make this say 25 and then say exit the sketch, and then I have to basically unclick edit the component, all of it gets automatically updated here. Now because I made the changes, I have to say save all, and then all the save is propagated back. So this is for a peg. You have something called as an advanced mate, which is known as a width mate. which is useful for trying to align a box to a cylinder or doing some weird, more interesting mates. So this is actually located under the advanced mate. So I want you guys to actually try to see if you're able to figure that out yourself. So you basically click on the advanced mate and then move this up, and then here are advanced mates. So you have profile, symmetry, width mate. So you can do like a path, linear coupler. You also have something known as mechanical mates, which is useful for gears, hinges, rack and pinion, screws, and so on. So this is kind of an exercise for you to try it out, and then if you want to do it, you can post a video and then I'll link to your video on YouTube. So that's the width mate, so you can do this for the square. The next one we wanted to do is a slightly more advanced mate, which is known as a tangential or a touch mate. So this is useful when you wanted to make, say, a square tangential to a curve. So here, now imagine I pull in my square that I previously created. Oops, that was mate, not insert component. So now I'm not actually sure how the block looks. So I basically have bring this block in here. And then now the block is kind of like free to move all over the place. I can basically make this face to be tangential. So I'm going to select this face, this outer face, and then I'm going to say make it tangential. So that basically means I have to look at the other view. So if you look at this, if I try to move this object, the face is always going to be tangential here. So if I draw a straight line over here, this is going to intersect. If I try to rotate this object, notice that it's continuing to go along the tangent, and so that is what the tangential mate does. So if you wanted to fully constrain a 3D object, the object itself has 6 degrees of freedom, right? So what do I mean by 6 degrees of freedom? So if I have this particular shape, this basically can move in and out of the plane, move up or down, move left or right. So that's 3 degrees of freedom. The other thing the object can actually do is rotate about this axis. It can rotate about this axis and then rotate about this axis. So that basically gives me a total of 6 degrees of freedom. So if you wanted to fully constrain the two objects, so if I have one object here and then I wanted to fully constrain these two objects, so imagine my first object is fixed. So I need to basically make sure that I get rid of all the 6 degrees of freedom to make sure that the second object doesn't move. So this, what can you make? So if you had a coincidental constraint, it removes 1 translational and 2 rotational degrees of freedom. So what do I mean by that? So let me grab 2 square blocks. So imagine I have these 2 square blocks. I take this face, make it coincidental. So basically either like this or like this, doesn't matter. So what happens? Because you're coincidental like this, I can't move. This is not permitted. This is okay. This is okay. Also, what I cannot do is I cannot rotate this block out of the plane, because if I do this, these two are no longer coincidental. So this is locked as well. Same way, I can't rotate it in the other view as well. So if I rotate it like this is no longer coincidental. So I need to keep this fixed. So the only thing I can do is move it like this, and then rotate the plane like so. So I basically get rid of 1 translational and 2 rotational degrees of freedom. So parallel constraint, the only difference is they're not coincidental, so they can still move in the same direction relative to each other. So you need to be aware of this so that you don't over constrain, and then if you're trying to particularly create some movement in your object, then you need to be aware to see if you have over constrained your object. So perpendicularity, 1 rotational constraint. So if you make 2 coincidental constraints, you still have 1 degree of freedom left. So you can think about why that is the case. You can think about 2 concentric cylinders. So we basically remove the axis, which removes 2 angles, and then you remove 2 positions. So you're basically getting rid of 4 constraints. You still have the z directional movement, which is kind of moving it up or down. So imagine I have this cup over here. I've constrained it like so. I cannot rotate the cylinder like this or like this. I cannot move it along this axis or this axis, right? So I've removed 4 degrees of freedom. So what I can still do is, let me put a dot here. So what I can still do is I can obviously move it in this plane. It's still concentric with my cup. I can also rotate it about this axis. So I have those 2 degrees of freedom left. In a cylinder, you're not really concerned about this rotation because it's axis symmetric, but you're concerned about the top and down movement. So you need to maybe insert an additional concentric constraint. So tangential constraint, so you remove one axis and one position is fixed. So you need to figure out how you will constrain them together. So the next thing we're going to look at is known as design toolboxes. So for this, you would basically click on your toolboxes. So you click on the corner here, and then the first thing you need to do is add your toolboxes. So we're just going to quickly see how that looks. So the toolbox is only available in my assembly. We can rebuild save, that's fine. So you have to click on this. It says design library, and then click on toolboxes. The first time you do it, you need to click add it now. So first time you open SolidWorks and do this, you have to click add now. It usually takes a little bit time. So hopefully if toolboxes are installed on your computer, you should see a view like this. So let me move this out of the way. So you have known the different standards that are used. So this is the ANSI inch, which is what is used in the US. So actually there's a nice US flag here. You have the ANSI metric, which is again used so ANSI metric is also used mostly in the US. So you have the AS Australian standard, you have the Chinese standard. Actually, I'm basically just going by the flag. So this is kind of like actually updated from the newer version. So actually you have the ISO standard, which is mostly the EU. So if you wanted to get metric stuff, you click on this, and then you have the different components that can be used. So you have bearings, you have bolts, you have nuts, keys, O-rings, and gears. So I'm just going to click on the gear and then show you how it looks. So I'm going to click the gear again. So I'm going to look for something known as a spur gear. So what you need to do is hold and then drag it into your diagram. And then for each component, it will actually allow you to configure it. So this one, I can kind of assign a part number. This is kind of like different parameters. So when you're actually designing the gear, you know what these would be. So I'm going to leave this as default. I'm going to kind of like fiddle around with the number of teeth, make it 20 teeth. Actually, my module became very small, so maybe I'll make it a little bit larger, make it 5. I can change this pressure angle, so don't worry about that. The face width, so from 12, this is kind of usually standardized, so you don't want to fiddle around with this. This is like if you have a shaft here, this is the nominal shaft diameter, so you might probably want to like slightly larger, so let's make it 10, maybe a little bit larger, 20, and then number of teeth, and then you can basically give comments and kind of fiddle around with this, and then say OK. So I can keep inserting the same gear again and again, but I'm going to hit escape. And then if I wanted to actually change the spur gear, so I'm going to right click and say edit. So instead of normal edit, I need to select edit toolbox component. And then if I wanted to go from say 20 teeth to 30 teeth, I have to wait for it to load. And then I'm going to select 30 teeth over here and then say OK. And then automatically my gear component is different. So this will be useful if you wanted to get screws, bolts, or any of the other common components which are commonly used in engineering but a little bit difficult to create it yourself. So this basically concludes our quick discussion on assemblies and assembly constraint, as well as how do you incorporate design components that are included in SolidWorks. Thank you.